So today we're going to refocus in case some of that stuff on there that we just did, in case some of that is like, ooh, I haven't done this in a while. Today I want to refocus on how to expand, which is maybe a fancy word for FOIL. Did you guys use that word with Quan last year? Foiling? Okay. Yeah, okay. So before I get to that though, let's start with just some terminology. We're going to focus on something called quadratics. It's a large unit we're going to do in we're not quite to that point yet, but we will get there. Quadratics are anything that has a degree of 2. What makes these things right here have a degree of 2? Do you guys remember what a degree is? Biggest exponent. Good job, yeah. See how the biggest exponent here is a 2? Here the biggest exponent here is a 2. The biggest exponent is a 2. Biggest exponent is a 2. These are all considered to be quadratics because they end up having something squared when you're done. That's the only requirement for a quadratic. Usually it looks something like this. There's a certain number of x squareds. There's a certain number of x's. And then this last one, sometimes it gets called a constant term. You guys use that vocabulary with Quan last year? Constant term? Okay. Does this one right here have a constant term? Actually it does. Did it get locked again? It actually does have a constant term. The constant term is 0. Yeah. We don't bother writing the plus 0, but we can actually consider there to be a plus 0 right there. How about this one right here? Could I write it with a middle term? Yeah, there are 0 x's. So we can always write it with a certain number of x squareds, a certain number of x's, and a constant term. Those numbers could be zeros, but that's what makes it a quadratic. One of the things you guys should have learned then last year is how to use maybe like these algebra tiles and how to FOIL. You guys do these tile things? No. Okay. What was that? Good. I hate them too. Yeah, so I'm going to show you a couple of methods for foiling though, in case maybe you've forgotten how to do this. The two main ones that I like are the box method and FOIL. So let me do some review here. Here's how the box method would work. You'd go x plus 3, put it up on let's say the top. You'd make kind of like a grid out of it, and you'd go x plus 2 along the edges. You guys ever do something like this? Yeah. Okay. So then you'd like in the middle here, you'd say, well, what is x times x? In this slot, it's x squared. 3 times x is 3x. X times 2 is 2x. And 3 times 2 is 6. And then last step, you'd have to combine the like terms. Are there any things the same? So 3 and 2 means that you have x squared plus 5x plus 6. We would call that quadratic because it has a degree of 2. We have 1x squared, 5 x's, and 6 numbers, constant terms. Probably the more likely way you're going to do this is something like this, where you go x plus 2 next to x plus 3. Maybe you did like, say, like a smiley face, where you do like something like that. Like that sort of method where you FOIL. That's another way you do it. So you go like x times x gives you x squared. Let's see, x times 2 gives you 2x. X times 3 gives you 3x. And 2 times 3 gives you 6. Either way, though, it gets you the same answer. Is this familiar? So today's goal, we're going to practice this a lot to make sure you're really solid at expanding. Let's try some. Why don't I do one, and then I'll have you guys do the next two. We already did the first one, though, didn't we? That's x squared. That's minus 3x. No, this one's different, isn't it? That's 2x and minus 6. Whatever method you use, doesn't really matter to me. Try expanding the next two. See that you get the same thing as me in a second. Does it matter what order you like do your FOIL in? It really doesn't, so long as you make sure everything gets multiplied at some point. So I mean, at some point you should have an x squared. At some point you should have a minus 6. You should have a minus 6x. No, a plus 6x. And a minus 1x. I don't care what order they get put in. But usually at the end of the day what we do is we always go with our x squareds first. Our x is second. And our constant terms third. So if you have this, you have the right answer? But if like along the way of getting there you get to go through a different method. Focusing well today?
Yeah.
Okay. It doesn't really matter which order these ones go in though, so long as you can get them to this final one here. Everybody else get this one here?
Yeah.
You guys want a second for the next one still? Okay. Do you guys have a specific method that Juan showed you as to like which order to do it in, or did he just let you do it whichever way worked? Like do you always do like first, outside, inside, last? When you FOIL?
Just did what he did.
Okay. Because like it doesn't really matter whether you do this one times that one first, and then this one next, and then this one. Like, you can kind of go in any order you want, as long as they all get multiplied. So at some point you should have a 2x squared. You should have an 8x. You should have a minus 64. Which one did I miss? Minus 16x. Again, I don't really care which order those 4 terms go in. Pick your own order, whichever one works for you. Just make sure you put them together at the end. So the 2 that go together, the 8 and the 16. So it looks like you should have 2x squared minus 8x minus 64. That makes sense? Wait, what happens if you don't have 2 brackets next to each other? Like what if they're not both in brackets? Well, you kind of do like a partial, right? You could do this 2 times is by this one, and the 2 times is by that one. So it's not quite the same thing as foiling. Often the word we use is expanding, but it's the same principle, right? So minus 2 times is by x to give you minus 2x, and minus 2 times is by minus 1 to give you plus 2. It's actually easier in a way. This one's the same sort of thing. That'll give you 6x squared and minus 10x. But now we make it more challenging. If I do this. You guys ever do something like this last year where you had a bracket, and a number up front? You guys did that? How would you go about solving it? That works, yeah. That's what I'd recommend. I'd take the 3 and I'd put the 3 into these guys here first. So that'll give you negative 6x and negative 9. And kind of like make that its own little bracket. And then FOIL that next to the 3x minus 4. Then FOIL this guy. So that'll give you a negative 18x squared. Let's see, this one will give you a plus 36. That one will give you a plus 24x. And that one's a minus 27x. Is that right? 18x squared for 1. That's a minus 27x. That one's a positive 24. And that one's 36, yeah. Minus 3x plus 36. There. There's our quadratic. Ellie. Sure. Jason. Yeah. Any issues with that one? Nope. Make sure you guys stop me if you do have issues, or at the very least, make sure you talk to me at another time. Because the pacing is certainly a lot faster than you might be used to. You guys ever do one like this? You do 3 of them. You done before? Alright, why don't I move over here?
Wouldn't it be easier to combine the 2x and the 4?
I think so, yeah. Like, let's find 2 of these and combine them together somewhere. What you could do is you could either like combine these ones together, or you could combine those ones together. But like we need to put at least 2 of them together first. Doesn't matter which ones though. Why don't we just put them together in order? Just maybe because that makes more sense to people. So what I'm going to do is I'm going to take this 4 minus x over here. I'm going to wait on it for a bit. And I'm just going to FOIL this stuff here. So 2x times x will give you 2x squared. So you're going to have a 6 in there. You're going to have a 3x. What did I miss? 4x. So just FOIL just this stuff here first, right? And then put it together. So let's make it 2x squared plus 7x plus 6. And then we can FOIL that into the next stuff. You ever do like a FOIL where it's not 2 versus 2, but like 3 by 2? The same principles essentially apply. You can't draw it out like a FOIL, but the idea is that everything has to times by everything. So like I might draw it like this. This 2x squared has to times by that 4. So that'll give us 8x squared. The 2x squared has to times by the negative x, which will give us negative 2x to the 3. I'm going to pick another color just to keep it organized. Not purple. Then I might do the 7x times the 4. So that's 28x. 7x times the minus x gives me negative 7x squared. And then, okay, so I've done the 2x squared times by both of these guys. And then the 7x times by both of these guys. I still have to do the 6 times by both, right? So 6 times 4 is, what, 24? And 6 times negative x is negative 6x. Rather than having just 4 terms to work with, now I've got 6 of them. You guys ever done one like this before? Okay. What's the last thing I should do then? Yeah, exactly. I'd like terms. So I'm going to start actually with the highest exponent. This is actually not quadratic, by the way, because my biggest exponent is the power of 3. So I'll put that one first. Negative 2x to the 3. And then my x squared. So it looks like I've got 8 right here and 7 right there, subtracting. So that's 1x squared. Then for my x's, there's 28 and minus 6. So 22. And then there's just that 24 sitting right here. So this actually isn't quadratic anymore technically because the power is no longer the power of 2, it's the power of 3. But that's expanding. What if we go really crazy? You guys can kind of see this just kind of builds in complexity, doesn't it? Eventually, let me just show you guys what we're going to eventually solve. This is what we're going to do by the end of the class.
Wow. Like this class today?
This class today. In 25 minutes, we're going to talk about how to solve this one right here.
We'll see.
We will.
Better get moving then.
Better get moving then. Okay, so let's give it a try. So what's different about these ones here then? Well, there's that plus sign in between, right? Well, it just means there's just more work to do, that's all. By the time we're done, we're just going to add more stuff together. So let's get cracking. This will give you 3x squared. That'll give you a minus 2x. Again, order doesn't really matter. You're going to have a 21x somewhere in there. And did I do that one? I did that already. What did I miss? This one here. Minus 14. But then I got to do the same thing on the other side. I'll pick a new color now. X times 2 will give me 2x. X times negative x will give me negative x squared. That'll give me a negative 6. That'll give me plus 3x. You taking off? Is it really harder work or just more? Wouldn't it be fair just to say that it's not harder, it's just you're doing the same thing just twice as much, right? Let's just put all of our like terms together now. I like to underline, by the way, so I would say like, I got 3x squared minus x squared, so I need 2x squared. Okay, minus 2 plus 21 is 19, plus 2 more goes back to 21, plus 3 more gets us up to 24, I believe. So there's 24 x's total. Minus 2 and plus 2 kind of cancel. 21 and 3 is 24. And then minus 14 and minus 6 is minus 1. There. There's our quadratic. Anybody get that? Able to follow that? Okay. Okay. So we're gonna want to put some work into more of that if we can. Let's try this one here. Let's just ignore that minus sign for a second. I'll get to that minus sign in a bit. Let's just practice our expanding again. Because this kind of is a skill we're gonna have to have down pat, right? 4 times 2x will give you 8x. 4 times 1 will give you 4. 3 and 2 is 6x. Ooh, hang on. Should be a negative 6x in there. Negative 6x squared.
8x plus 4.
Let's see, I do that right? This will be an 8x between these guys here. And then the 4 and the 1 will be a 4. This will give you a negative 6x squared, and then that one will give you negative 3x. Again, if you do those 4 things in a different order than I do, I don't care, right? So long as you have all 4. Okay, for the next one, do the exact same thing. So 5x times negative x is negative 5x squared. 5x times 1 is 5x. That'll give you a plus 2x and a minus 2. Anybody know how to deal with the minus sign? You know what this minus ends up doing? Yeah. There's a couple ways you can approach this. Okay. One way is that you can flip all of these guys right here. You can just change all their signs. So essentially, a negative now becomes a positive. A positive becomes a negative. Positive becomes a negative. A negative becomes a positive. But this negative needs to distribute through all of them. So you got to flip all their signs. So now when I put it together, that actually gives us a negative x squared. Let's see, 8 minus 3 is 5. Minus 5 gets us 0. Minus 2 should give us negative 2. And then 4 and 2 should give us 6, hopefully. You got that too? So, yeah, make sure you're very careful with distributing that negative. Okay, I'm going to say this a lot over the first week and a half here. If this is something that on our Jenga pyramid, you know you're struggling with, where it's like, oh my goodness, this piece is missing, and this piece is missing, and it's teetering, you got to chat, right? It means come into focus. Let me know. I can help you target it. I'll work with you on a one-on-one basis. Because here's my goal. That, believe it or not, should have all been reviewed. Like really, none of that was actually something that we've done that's new. We all did that last year. Now the question is, can we solve equations? That's actually the goal of our whole first unit. Our unit is on algebra. Algebra essentially, guys, can you focus please? Algebra is where we want to try to solve for what x is. Right? We actually want to try to get an answer where x is 5, x is 7, right? So we want to now use those skills and solve something like this, or believe it or not, we can solve this. We will. I got 20 minutes, let's try this. The difference now is there's an equal sign. Does it change our first steps though? Not really, right? Like we still just keep expanding. X times x, x squared. 7 times minus 2, minus 14. What did I miss? 7 times x is 7x. X times minus 2, minus 2x. Well, do the same thing on the other side. X times x, x squared. X times 3, 3x. Whoa. Back, we're good. Negative 1 times x, negative x. Negative 1 times 3, minus 3. But now it's algebra, right, Jordy? Can you focus, please? I don't want to go through what we did in science last year. If you guys are going to be that corner back there, I'm going to have to split you up because you're not focusing. It's day 1. Okay. What's the goal of algebra? What are we trying to get? X. Okay. Here's the issue, though. We have some x's, but we also have some x squareds. I actually showed you one of these earlier in the class, though. See how there's an x squared right here and right here? Exactly. Yeah, they'll cancel. Yeah. Oh, yeah, we can solve this then. Let's put all of our x's on one side. Normally, you don't want your x's together, but in math we do. It's a bad joke. So let's put all of the x's on this side here. So let's subtract 3x from both sides. I'll get rid of those ones. Let's add x to both sides. So over here you've got 7x minus 2, so that's 5. Minus 3 is 2. But go back up by 1. 3x on that side. We want to put all our numbers on the other side. So all we have here is the minus 14. So let's add 14 to both sides. Minus 3 and 14. And then divide by 3. Truthfully, leave it there. You could grab your calculator and find out what it is as a decimal, but I think if you learned one thing today, it's that there's no point. How does it help? Right? It means you have to round. Rounding is never a good thing. It always means you lose your accuracy. If we want to use the words from physics. So don't bother rounding. Just leave it as 11 over 3. When I teach kids math, I guess you guys haven't had me for math yet. I like to sometimes say I think there's 3 levels of understanding in math. The first level is actually really you don't actually understand at all. And so if you're being truthful, you go, it went over my head, I didn't get it. That's like level 1. Okay. If you're at level 1, we got to chat, okay? Level 2, to me, is where I show you something and you go, I followed that. You go like, you didn't lose me, all that made sense. And that's a good place to be at. Level 3 is the most challenging one though. where then I ask you to do it by yourself and say, I'm not going to help you. I've shown you the steps. You have the skills. You have the tools in your toolbox. Your pyramid there of Jenga is complete. You do it by yourself. That's level 3. Anybody think they're at level 2 where you're like, I followed? 2.3. Okay. So here's one. I promise you, you have the skills. We've talked about the skills for this. Try it. We've got 15 minutes left. See whether you can do it by yourself. I mean, I'll go over it with you, obviously. Ooh. Yeah, this is the next one. You guys know how to combine like terms. You know how to FOIL. You know how to deal with the plus sign in between here. We've done all these pieces before. This is level 3. Can you do it yourself without help? That's fine. Try it, right? I'll do it in 5 minutes or so.
Hello, Watson. Can you please call 3500? Hello, Watson. Please call 3500.
Huh? You ever come across a problem like this in real life? Well, no. But I want to make sure that you guys get the point behind why we teach math and what I'm going to try to do for you guys with math. There's no point, particularly in solving this, that there's like some sort of big goal. I promise you that math is useful in everyday life. Here's the point, though. If I would have shown you this question or the one we're going to do after at the beginning of class, a few of you, your eyes kind of popped a little bit and went, that looks really hard, right? But isn't that the whole point of, I showed you a couple of skills that you kind of possess, and now say, can we take it to the next level? Can you challenge yourself to try something new and difficult? Hey. Yes. Okay. The whole point behind a question like this one and the next one is not that it's going to be this specific thing is something useful that you'll do one day in life. The goal is, can you take what someone showed you, and can you take it that just one step further? Can you challenge yourself? Can you problem solve? Can you do something that seems too hard and get through it? And if any of you guys have done, I don't know, even like faces is probably a good example, right? Where you didn't think you could do it, and then you discover, yeah, good. It's a good feeling. Right? And if some of you guys end up getting this question or the next one right by yourself without my help, you're gonna feel like $1 million. Because you're gonna be like, I can do this. If you don't get it right, that's okay then too though, right? The key then is to figure out which one of these blocks where you miss it. Did you not know how to factor or add or expand, right? And see how we can help fix that. I won't, I'll be quiet still, but I'll start just kind of doing a little bit of work and see whether, I'll just write it down on the board, see whether I need to get the right answer. I got to a point here where at some point I got that like x was equal to negative x was equal to 0. Yep. X is 0? Yeah. Apparently x is 0 in this one here. I got actually negative x is equal to 0, but if I went the other way, I think I could have got positive x equals 0. Let's check that real quick. Let's do some work in our head here. If it was 0 plus 1, then this would be a 1, right? And if that was a 0, that would be minus 3. 2 times 1 is 2, times minus 3 means this side would be minus 6, if those are zeros. Then if that's 0, then that kind of goes away. And if that's 0, it kind of goes away. So minus 4 times minus 2 would be minus 8. And then if that's 0, it goes away, and if that's 0, it goes away. 1 and 2 would give you 2. Is minus 6 equal to minus 8 plus 2? Yeah. Out of curiosity, anybody pull 0 at all? That's awesome, guys. Like, truthfully, that's fantastic, right? If I showed you this question at the beginning of class, you probably would have been like, ooh. Now, here's the thing. If you don't get it, don't freak out, right? I mean, it's day 1. Who's graded everything the first minute? That's fine. The key is, let's try to figure out where you went wrong so we can get better. So here's my last challenge. Let's try this one. You guys brave enough to try it by yourselves? Yeah. Or do you want to do it as a group?
Try it by ourselves.
Do it by yourselves?
I
don't even know how to start.
Let's do it as a group. Let's do it as a group. I don't want to go too far too fast. So where should we start on a question like this? What do you possess the skills? Like, what do you see that you can do? Yeah, you can FOIL this little bit right here, right? Let's start with that. So let's FOIL this mess here. You'll get a 6x squared. You'll get a 4x. You get a negative 9x. And you get a minus 6. So I'll just kind of color code it. This crap in red right here, that's right there. Below it, I'm going to leave the x plus 2. Let's work on this stuff here first. 7 times this by 2 for 14. 7 times by x for 7x. Minus sign. Warning bells. Minus signs mean you need to like flip all your signs around, right? So it's like, if you're supposed to have an x, now you have a minus x. And if you have a 1, now you have a minus 1. You guys see why I brought the Jenga blocks out? Solving a math problem is like putting 50 Jenga blocks together. It's the sum of a whole bunch of little pieces, right? So far, I've done a little bit of foiling right here, a little bit more foiling, but I've got more to do, right? Like now I'm going to pull out the skills of combining like terms. What sort of terms can get put together? Well, right here I can put these ones together, right? So I can make this 6x squared minus 5x minus 6. I can put those ones then. What about on this side right here? We can do the same thing, right? So there's 6x over there and 13. It's the next block on the tower. We have already been at this point sometime earlier today. How do you fix a fraction? You take this whole bottom part right here and you swing it up top to multiply. That's a skill we have, right? Well, maybe you don't, right? Again, the Jenga thing. If that's something that you're not very good at, you don't know how to deal with fractions, the whole puzzle breaks, you know what I mean? So that's what I need you guys to start working on with me. Identify where the breakdown falls so that we can fix that. Because this is no different than 3 over 2 equals x, and you times the 2 up. It's the same thing, right? So let's time the x plus 2 up. It means that what you're going to have now is 6x squared minus 5x minus 6, 6x plus 13, but there's an x plus 2 next to it. Because you brought this x plus 2 up next to that guy. Alright, do some more foiling then, right? Foil this stuff over here. So I'll just keep writing this. 6x squared minus 5x minus 6 equals 6x squared plus 13x plus 12x. No, not plus 12x. I did wrong. 6x squared, 13x, oh no, 12x. 12x and 26. There. All right, what's the next block on the Jenga tower? We need to combine like terms. Actually, before I do that, maybe you'll even notice this next other block we talked about today. Look, there's 6x squared right here. There's 6x squared right there. They're canceled. Okay, now let's combine like terms. Right over here, that's 25x. And I'm going to add 5x this way here. Get rid of that little mess. So I should have 30x's on that side there. If I subtract the 26 off of this side over here you should have negative 32. X is minus 32 over 30. We can actually go one step further. There's another block that I haven't even talked about today, which is reducing. Both these numbers you can divide by 2. So the best answer would be negative 16 over 15. Think of it like a Jenga tower. I really want you to think of it like that, because that's where math is starting to go. We don't do one-step problems anymore. We're doing fairly complex problems. And this is across dash 1 or dash 2, by the way. Doesn't really matter which string we're in. This still is across both strings. Okay. So as you're packing up, one last thought here. I really want you to focus on figuring out where your holes are. If you know, for whatever reason, that you're really struggling on, I don't know, multiplying, we got to figure out how to fix that. I will work with you guys, okay? So these journals right here, if you're going to use them, feel free to take them with you. Honestly, if you're not planning on using them, throw them back in the bin, okay? But the goal is at the beginning of every class to find something that you can work on that you know you're struggling with. Call me over, I'll help you. Does that make sense? Tomorrow we're going to do one more lesson, and then after that we got a couple of work days because your assignment's due Friday, okay? Okay, you guys can take off. We'll see you later.